Electromagnetism is one of the basic forces of nature and it plays a crucial role in the world around us. It is responsible for a wide range of things we see and use every day, from light to electricity to the magnets that stick to our refrigerators. Understanding electromagnetism helps us to grasp how charged particles like electrons and protons interact and how these interactions lead to important phenomena in both science and technology. At its simplest, electromagnetism is the force that occurs between particles that have an electric charge. This force can either push particles apart or pull them together, depending on their charges. Opposite charges like positive and negative attract each other, while like charges like two positives or two negatives will repel each other typically. The study of electromagnetism is split into two main parts: electrostatics and magnetostatics. Electrostatic focuses on electric charges at rest and the electric fields they create. Imagine you rub a balloon in your hair and it sticks to the wall. This is a simple example of electrostatics. The electric field is a kind of invisible force around us, around a charged object, and it can cause other charges to move or stay in place. Magnetostatics deals with magnetic fields created by steady, unchanging electric currents. For example, when electric currents flow through a wire, it creates a magnetic field around the wire. You can observe this by placing a compass near the wire. The needle will move, showing that the magnetic field is affecting it. Magnetic fields are the force behind magnets sticking to your fridge and the operation of your device like electric motors. One of the biggest breakthroughs in science was realizing that electricity and magnetism are actually connected, forming a single force, electromagnetism. The scientist James Clerk Maxwell played a key role in this discovery by creating a set of equations now called Maxwell's equations, which describe how electric and magnetic fields interact. One of the most important things these equations showed was that changing electric fields can create magnetic fields, and changing magnetic fields can create electric fields. This relationship is what allowed electromagnetic waves to exist. Electromagnetic waves are simple waves of energy that move through space. These waves include visible light, which is what our eyes can see, as well as the other types of radio waves: microwaves, infrared, ultraviolet, X-rays, and gamma rays. Each type of wave has different uses. For example, radio waves which carry music to your car. Microwaves heat your food. X-rays let the doctor see inside your body, and so on. The way electromagnetic waves interact with matter is also fundamental to our understanding of the world. When light hits an object, it can be absorbed, reflected, or transmitted depending on the material. The colors we see are the result of how different materials reflect or absorb different wavelengths of light. This understanding is key in fields like photography, where the behavior of light is crucial. Electromagnetism does not just explain how light is also the force that holds atoms together. Inside every atom, negatively charged electrons are attracted to positively charged protons in the nucleus. This attraction is what keeps electrons in orbit around the nucleus, much like planets orbiting the sun. When atoms bond together to form the molecules, it is the electromagnetic force that is responsible. The vast variety of materials we see, everything in the water to plastic to metal, is due to different types of electromagnetic form bonds between atoms. In living organisms, electromagnetism is vital as well. For example, the human nervous system relies on electrical signals to send messages between different parts of the body. Your brain communicates with your muscles through these signals, allowing you to move, feel, and respond to the environment. Medical technologies such as the MRI scans use magnetic fields to create detailed images of inside your body without needing surgery. Electromagnetism is also the heart of many technologies that power our world today. The electricity that lights our homes and powers our devices is generated using principles of electromagnetism. Electric motors, which convert electrical energy into mechanical energy to do work, are found in countless machines like fans to cars. The development of communication devices like the telegraph, telephone, and radio all rely on electromagnetic signals to transmit information over long distances. In recent years, advances in our understanding of electromagnetism has led to even more incredible technologies. Semiconductors, which are materials that control the flow of electricity, are the building blocks of all modern electronics, from smartphones to computers. Quantum electrodynamics, a branch of physics that explores the interactions between charged particles and electromagnetic fields, at very small scales is leading to development of quantum computers, which could revolutionize computing. Even in space, electromagnetism is important. Earth's magnetic field shields us from harmful solar radiation, and studying magnetic fields in space helps scientists to understand phenomena like solar flares and auroras. Light from distant stars and galaxies, which is a form of electromagnetic radiation, allows astronomers to study the universe and learn about its history, composition, and structure. In summary, electromagnetism is a powerful force that is central to our understanding of the natural world and has driven many of the technological advancements that shape our lives. From the tiny atoms that make up all matter to vast reaches of space, electromagnetism influences nearly everything. As our knowledge of this force continues to grow, so too does our ability to harness it in ways that could transform the future.